Somebody grumpy. Needs some coffee.
Monaco tell history and periodic law.
Okay, still waiting. When
Need learning target. Smash.
yeah, so Monaco will be able to describe with you the origin, history, and the arrangement of said periodic table.
Unless I get angry, and then I will unarrange periodic table.
And then I will be forced to rearrange it once again because I'm OCD.
But first,
Mendeleev.
Mendeleev, Dmitri, Russian, 1800s.
Long time ago.
Not that long.
But Mitzer, it's mad long.
I mean, it was like yesterday. Yeah,
I can't remember 2 days ago. So
he was a lecturer at the University of St. Petersburg.
that is a professor.
Yes. He was very important to the Russian industry and commerce. He also came up with the standard as to how Russian vodka is made. But we're focused on the periodic table.
Yeah, refocus.
He arranged the elements by their known atomic masses from the lowest to the highest.
Yeah.
When the masses were known, there was a way that they could do it. They could figure it out, totally different than how we do it nowadays. But he then grouped them in vertical columns by their similar reactivity. He knew potassium and sodium reacted similarly, so he kind of put them in the same column. And when he was all done, he saw big gaps in their masses and the properties, and he left these spaces empty. You can kind of see them here. See, there's some blank spots. These were all the known elements at the time. And he was like, 139 for lanthanum. There must be something before we get to tantalum at 181. So he left a gap there. He's like, there's too big of a step there. I got to figure something out. Something must go in there. And that's what the big deal for this guy was, because in the future, new discoveries led to finding those elements, and they fit perfectly into the spots that he had left. So that's why we actually remember who he is today, because he predicted, as of yet, unknown elements in their properties, their masses, and how they would react, which was at the time just like mind-boggling.
Right. But the gaps still presented a problem nonetheless because there were gaps, right? So then came Moseley and the modern periodic table. Now, Moseley is a British chemist who took Mendeleev's periodic table, and he rearranged it just a little bit more into what we actually have today and still use, right? So protons and other subatomic particles have been discovered since Mendeleev's time, because that was mad long ago, right?
Yeah.
Look at his lab.
Mendeleev didn't know about protons, neutrons, or electrons. He
no.
might have heard about electrons, but he wasn't really familiar with how it all worked with atomic
Right, and
structure.
just in the picture, you can see that he had a lot more to work with, Moseley. Okay, he had stuff.
Yeah,
and that was
look at
cool.
that
Like there was
awesome lab.
electricity,
Right.
So now he ordered the elements based on increasing atomic number, the number of protons, how they've been proven. Now that's the key difference, so you got to take special note of that. One was mass, one was atomic number, and now something else happened. He kept the vertical groups, similar properties, right? And now formalized periodic law. The gaps went away. If you had an element that had a mass of 7, what would you think the next mass would be? 8 or 9? And it's not as predictable. And if you were to look across the periodic table, you'd see that. But if you have 1 proton, what comes next? 2, what comes next?
3.
Now, these are all matter-of-fact things, and then now it lines up a lot better.
Because Moseley knew that protons gave the identity of the elements. Hydrogen had 1, helium had 2. You can't have 1.5. There's no element in between there because you can't have half a proton. So his table was complete.
Sure. And we learned last unit that the average atomic masses that are listed on the periodic table are based on different isotopes of the same element. What didn't change about that? The number of protons.
So when he had all his 118, 110 elements listed up and categorized both vertically and horizontally, he was able to predict the properties of elements without actually testing them.
And now what we talk about is
true.
Everybody in group 1 starts a new row, starts a new energy level, 1 valence electron. Get to the end, fold up, everybody's got 8 and non-reactive. And so you can start to see there's metals on one side, there's non-metals on the other, and the properties get very predictable.
And the act of adding more protons to the nucleus with more neutrons and electrons progresses you from the left to the right across the periodic table, and the properties of the elements change accordingly as a result.
Sure. And unfortunately, we only have 2 scientists So somehow you really didn't get into that.
Do you want to click the
Next
button?
You want to
Stop the
click the
recording?
button?
You want to click? You got to sing the
Oh.
song. Click the button and turn off the video. Click the
The
button and
I'm not as fast.